Hello, dear student. Miscellaneous of 3D chapter we are going to do. First question, so that the line joining the origin to the point 211 is perpendicular to the line determined by the point 35 minus 1 and 43 minus 1. Now, let OA be the line joining the origin. So first of all, this type of question, how we can solve? First of all, we have to find out the direction ratio. This is very important. Once we will find out the direction ratio and condition A1, A2 plus B1, B2 plus C1, C2 equal to 0, then easily we can prove the two lines are perpendicular. So first of all, let the origin be O and the point is given 211. So this is the origin and the point A is 211. So when we are joining the point and of these 2 points, same way BC is the line joining the point B and C. This is the point. So OA, direction ratio of OA, first of all we have to find out. So OA is nothing but 211, because 2 minus 0, 1 minus 0, 1 minus 0. This is direction ratio of OA. Similarly, for the BC, direction ratio 4 minus 3, 3 minus 5, minus 1, minus 1, minus minus plus here. So this is 0. So direction ratio of BC is this. So we got the direction ratio of OA and direction ratio of BC. After that, OA is perpendicular to BC if A1, A2 plus B1, B2 plus C1, C2 equal to 0. So A1, A2, B1, B2, C1, C2, we have to substitute the value and it is coming 0. So definitely OA and BC are perpendicular to each other. Question number 2. L1, M1, N1, L2, M2, N2 are direction cosine of two mutually perpendicular lines. So that direction cosine of the line perpendicular to both of these lines are this. Now already it is given direction cosine of two lines. Now another line which is perpendicular to this line and this line, which is perpendicular to both the line, and direction cosine of this line is this value that we have to prove. Now it is given already L1, M1, N1, L2, M2, N2 are direction cosine of two mutually perpendicular lines. So if two lines which are mutually perpendicular to each other, then the condition is L1, L2, M1, M2 and N1, N2 product is equal to 0. This is the first condition. Now already we know if the direction cosine is this for the one line and direction cosine is this for the other line. So L1 square, M1 square, N1 square is equal to 1 and L2 square, M2 square, N2 square is equal to 1. So this three very important information based on the two lines when it is perpendicular to each other and direction cosine is given. Now L, M, N, we are taking the direction cosine of the line which is perpendicular to the line whose direction cosine are L1, M1, N1 and L2, M2, N2. So we are taking the direction cosine L, M and N which are perpendicular to the line whose direction cosine are these two. Now, if this is perpendicular, then we can take the condition of the perpendicular, that is L1, M1, N N1 equal to 0, L2, M2, N N2 equal to 0. Now from here we can take L. Now we are going to solve for the L, M and N value. So L divided by L we are taking, this is the cross multiplication, we know, M1 N2 minus M2 N1. Similarly for the M we can write here N1 L2. So in this case, first we have to cross multiply this value and after that this value N2 L1. N and third n divided by L1 M2 minus L2 M1. This is the third value. So once we will squaring, because we required L square, M square, and N square value, this is 1. So what we have to do, if we square this value, if we square this value and square this value, after squaring this value, this is the thing, it will come. Now, L square, M square, and N square. Now, after adding this, now here the most important part is here. Now from here we can write here just adding the value, and this is the equation 4. Now L, M, N are direction cosine of the line. So direction cosine, this is the condition, L square plus M square plus N square is equal to 1. And we know that this is very important. L square, M square, N square, L2 square, M2 square, N2 square. So this is the squaring value. And here L1, L2, M1, M2, N1, N2 whole square. This, when we will calculate, this is the direct value. So from the first, second, and third equation, this value is 1, this value is 1, and this value is 0. So just we have to substitute the value here, and this total value is, if we'll calculate, then this is equal to 1. Now this fifth and sixth equation, what we got, just we have to substitute in the equation first, in the equation 4. When we will substitute 5 and 6 equation in the equation number 4, then we are getting L square by this value, M square by this value, N square by L1 M2 minus L2 M1 whole square is equal to 1. So we can write here M1 N2 minus N2 N1, this is the L, this is the M, and this is the N value. So direction cosine is nothing but, this is the direction cosine of the given line, which is L, M, and N, which is perpendicular to the line L1, M1, N1, and L2, N2, N2. So this is the proof. Next question, question number 3. Find the angle between the lines whose direction ratio are A, B, C, and B minus C, C minus A, A minus B. Now, if the direction ratio is given, we know that A into B minus C, A1, A2 plus B1, B2 plus C1, C2 divided by root under A1 square, B1 square, C1 square, and A2 square, B2 square plus C2 square. This is the angle. Now, in this case, first value is A and B minus C. A, B minus C, B, C minus A, and C, A minus B. This is the product of this two direction ratio divided by A square plus B square plus C square, B minus C whole square, C minus A whole square. Now, in the numerator part, once we will solve AB, this is AB minus AC plus BC minus AB plus AC minus BC. So AB will cancel, BC will cancel, AC will cancel. So this becomes 0 divided by, this is nothing but some number. So angle is cos inverse 0 is 90 degree. So in this way, if the direction ratio is given, easily we can find out the angle. Question number 4. Find the equation of line parallel to x-axis and passing through the origin. Now, the line parallel to x-axis and passing through the origin is nothing but the x-axis itself. So, let A be a point on x-axis. So, this is the x-axis, and in this x-axis, therefore, the coordinate of A we can take here. This coordinate is A 0, 0, where A belongs to some real value. Now direction ratio of OA is nothing but A minus 0, A 0, 0. So equation of OA we can write x minus 0 by A, y minus 0 by 0, and z minus 0 by 0, because this is the direction ratio and this is the point. Origin, the line passing through the origin. So equation of line x minus x1 by a, y minus y1 by b. So this is the value 0 and this is the point. So equation is, we can write x by 1, y by 0, z minus 0. This is equal to a, we can write. So equation of line parallel to x-axis and passing through the origin is x by 1, y by 0 and z by 0. Question number 5. If the coordinate of the point A, B, C, D, this is the A, B, C and D. Find the angle between AB and CD. We have to find out the angle between AB and CD. So coordinate of ABCD are, this is the coordinate of ABCD. Now ABCD is given, so direction ratio of AB we can write here. That is, this is the A and this is the B. So 4 minus 1, 5 minus 2 and 7 minus 3. This is the direction ratio of AB, and direction ratio of CD we can write 2 minus minus 4, 9 minus 3 and 2 minus minus 6. So this is the direction ratio of CD. Now if we observe here, this is 3 and this is 6. This is 3, this is 6 and this is 4 and this is 8. So if we will take the ratio 3 by 6, 3 by 6 and 4 by 8, A1 by A2, B1 by B2 and C1 by C2 all are 1 by 2. So therefore AB is parallel to CD. Thus the angle between AB and CD is either 0 degree or 180 degree. Now question number 6. If the line x minus 1 by minus 3, y minus 2 by 2k, z minus 3 by 2, and x minus 1 by 3k, y minus 1 by 1, z minus 6 by minus 5 are perpendicular, find the value of k. K is unknown here, that we have to find out. Now direction ratio of both the line first we have to find out. So direction ratio of the line is, for the first line, minus 3, 2k and 2, and for this 3k, 1 and minus 5. This is the direction ratio. Now we know if two lines which are perpendicular to each other and whose direction ratio are a1 b1 c1, a2 b2 c2, so we can write perpendicular condition a1 a2 b1 b2 c1 c2 sum is equal to 0. So just we already got the value of a1 a2 b1 b2 and c1 c2. Just we have to substitute and solve. The value of k is minus 10 by 7. So the given line are perpendicular to each other. Question number 7. Find the vector equation of the plane passing through 1, 2, 3 and perpendicular to the plane. Now we have to find out the vector equation of the plane. Find the vector equation of the plane passing through the 1, 2, 3 and perpendicular to the plane. Now first of all the point is given, so based on that the position vector of the point first we have to write 1, 2, 3. So r1 equal to I plus 2j plus 3k. First, according to the given point, we have to write down the position vector of the point. Now this is the plane r dot n equal to d. This is the equation of the plane. So r dot I plus 2j minus 5k plus 9 equal to 0. So this direction ratio of the normal to the plane, this is the equation of the plane that is given, r dot I plus 2j minus 5k plus 9 equal to 0. So this is the value 1, 2 and minus 5. This is the direction ratio of the given plane. And normal vector, this is the r dot n. The formula is r dot n. So normal vector is I plus 2j minus 5k. Now the equation of line passing through the point and perpendicular to the given plane. We are writing L equal to equation of the line r plus lambda n. So r value is position vector that we got. This is the point plus lambda n. and which is perpendicular to the given plane. So this value we have to substitute and get the equation of the line. Now question number 8. Question number 8. Find the equation of the plane passing through ABC and parallel to the plane. This is the equation of the plane r dot I plus j plus k equal to 2. Now, any equation of the plane which is parallel to the another plane, we write the equation of the form. Suppose this is the given plane. Now, with respect to this plane, I want to write a equation of the plane. So we can take r dot, only this value will change, rest value is same. So r dot I plus j plus k equal to lambda. So our task is to find out the value of lambda as well as r. Okay, now it is given this plane is passing through ABC. So passing through ABC. So first of all, this position vector r of this point r equal to ai plus bj plus ck we can take. This is the point and this is passing through ABC. So first of all, we have to convert this into the vector form. So point we can write ai plus bj plus ck and we have to substitute this value in place of r. So ai bj ck I plus j plus k equal to lambda. Now dot product if you will take, then I dot I1, so a plus b plus c equal to lambda. This value of lambda we have to substitute in the equation first. In this equation, if you will substitute here, so r dot I plus j plus k equal to a plus b plus c. This we are taking as a second equation. This is the vector equation of the required plane. Now substitute r equal to xi plus yj plus zk. So in the equation first, just we have to substitute the value and xi plus yj plus zk I plus j plus k equal to a plus b plus c. So x plus y plus z equal to a plus b plus c. This is the required equation of the plane. Question number 9. Find the shortest distance between lines. The line is given r equal to 6i plus 2j plus 2k plus lambda I minus 2j plus 2k, and r equal to another line is given. This is the another line. So we have to find out the shortest distance between these two lines. Now there is a direct formula for the shortest distance. Now line is given, this is the two lines. So suppose the line standard format is r1 equal to a1 plus lambda b1 and r equal to a plus a2 plus lambda b2, which is in the equation first and second. Like this is showing, this is corresponding value, like this is suppose r, and another equation which is representing the second equation. So this shortest distance is given by, for the line is b1 cross b2 dot a2 minus a1 divided by mod of b1 cross b2. So this is the shortest distance. So whatever the equation is given, first of all we have to find out b1, b2 corresponding a2 and a1, and after that individually we have to solve each and everything, and after that we have to substitute in the formula. Now, when we are comparing from r equal to a1 plus lambda b1, r equal to a2 plus lambda b2, then this is the value. a1 equal to 6i plus 2j plus 2k, b1 equal to I minus 2j plus 2k. Similarly, a2 equal to this and b2 equal to this. Now, first of all, we have to find out a2 minus a1. For the a2 minus a1, this is the a2, this minus a1. So a2 minus a1 is, this is the value. Similarly, we can find out, just we have to compare from the standard equation and a1, b1, a2, b2 value we had written. After that, we required a2 minus a1, so we subtract a2 minus a1. We required b1 cross b2. So this is B1 and this is B2. So for this B1 cross B2, here we have to write ijk in the determinant format. This is 1, minus 2 and 2. This value in the second row and 3, minus 2, minus 2. This is in the third row. After solving this equation, this value B1 cross B2 determinant value, we got B1 cross B2 value is, this is the 8i. This is the value B1 cross B2. So modulus of B1 cross B2 is 8 square plus 8 square plus 4 square. 8, 8 and 4. So square value we have written here, that is equal to 12. So in the numerator we required B1 cross B2 dot A2 minus A1. So B1 cross B2 is this value and A2 minus A1 is, this is the value. So dot product of I dot I, so minus 80, 8 into minus 2, minus 16, 4 into minus 3, minus 12. So this is the value minus 108. Now, in the given formula, all the value for the numerator and denominator we got, just we have to substitute the value minus 108 by 12. This is the 9 unit. Question number 10. Find the coordinate of the point where the line through 516 341 crosses YZ plane. So this is the point, and this point is passing through, and this is lying on the some line, and it is passing through YZ plane. So in this type of question, it may be changed YZ plane, XZ plane, anything is given. So a step is fixed. First, you have to find out the equation of line. Well, after that, whatever the point you will get in that YZ plane, that means X value you have to equate. This is the second step. And third step, whatever the value we will get for the constant, just we have to substitute in the 3 points. This is the 3-step problem. So this type of problem is very, very important. So just you can see. Now we know that equation of the line passing through the point x1, y1 and z1, x2, y2, z2. So equation of the line is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, and z minus z1 by z2 minus z1. And this is the required equation of the line when it is passing through 2 points. Now, always remember this is the same as 2D. Like y minus y1, we are getting m bracket x minus x1. In the 2D, when the 1 point fall. Now, what is the most important thing? There is no any slope concept is there in the 3D. So in place of slope, what they did, they find out the direction ratio. So this all values in the denominator you can see here. This is nothing but the direction ratio. So if 2 points are given, then easily just we have to subtract from the 1 point to another point, and we will get the direction ratio. And after that, x1, y1 and z1, any 1 point we can take and find out the equation of the line. So this is the major concept. So line passing through the point 516, 341. So for this, we can find out the equation of the line. So just we have to substitute x minus 5, y minus 1, z minus 6. This is the 1 point we took from the 2 given points. So like 516 we took. So 516, after that x2 minus x1, y2 minus y1 and z2 minus z1 we got it. So after that, just we have to take this as a constant k, because this is the ratio. So x minus 5 by minus 2, y minus 1 by 3 and z minus 6 by minus 5. So x equal to 5 minus 2k. So when we will multiply for this, we can find out 5 minus 2k, y equal to 3k plus 1 and z equal to 6 minus 5k. So any point on the line is the form of, we can write this is the point which is lying on the line. So since the line passes through the YZ plane, so YZ plane means x value is equal to 0. So 5 minus 2k equal to 0. So k equal to 5 by 2. So when we got the k equal to 5 by 2, after that just we have to substitute here, here and here, and we will get the our required point. 3k plus 1, k equal to 17 by 2, 6 minus 5k minus 13 by 2. So the required point is 0, 17 by 2 minus 13 by 2. This is the answer. Question in like a question number 10. Find the coordinate of the point where the line, this is the line 5, line through the point 516, 341. And now it is a line is passing through the ZX plane. So in this time, y equal to 0 we will take. So equation of the line passing through the point x1, y1, z1, this is the required equation of the line. This is the equation of the line. Now the 2 points are given 516, 341. So we have to find out this value. Just taking one point. This is nothing but the representing the point, and this is the direction ratio of the line. So this we take as a k, and we have to find out the x, y, and z value. So any point on the line is the form of 5 minus 2k, 3k plus 1, and 6 minus 5k. Since the line is passing through ZX plane, so ZX plane y value equal to 0. So 3k plus 1 equal to 0, k equal to minus 1 by 3. After that, just we have to substitute in the given point. So in here, and here we have to substitute and get the result. So 5 minus 2k is 17 by 3. Obviously, y value is 0, and 6 minus 5k, 23 by 3. So this is the required points. Question number 12. Find the coordinate of the point where the line through 3 minus 4 minus 5 and 2 minus 3 1 crosses the plane. Now, line is passing through this 2 point, but line is crossing the plane. This time, now this is the plane it is given. It is same similar type question whatever we discussed earlier. Now, first of all, from the given point x1, y1, z1, x2, y2, z2, we have to find out the equation of the line. So equation of the line we can take like this. This is the one point we took, and this is the direction ratio that already we saw. So this is the point. This is the point we can take. X equal to 3 minus k, y equal to k minus 4, z equal to 6k minus 5. Now, any point on the line is, this is the point. Now, this point lies on the plane 2x plus y plus z equal to 7. So definitely this will satisfy. So we have to just substitute the value in the plane. So 2, 3 minus k minus 4, 6k minus 5 equal to 7. So 5k minus 3 equal to 7 and k equal to 2. So coordinate is required coordinate. We can find out 3 minus, just we have to substitute this value in the given here and here. So after substituting the value, we are getting the coordinate of required point is 3 minus 2, 2 minus 4, 6 into 2 minus 4. That is 1, minus 2, and 7. So this is the required point. Question number 30. Find the equation of the plane passing through the point minus 1, 3, 2 and perpendicular to each of the plane x plus 2y plus 3z and 3x plus 3y plus z equal to 0. Now, we know the equation of the plane passing through any given point. The formula is a x minus x1 plus b y minus y1 plus c z minus z1 equal to 0. Here the point is given minus 1, 3 and 2. So just we have to substitute a x plus 1 because this is minus, so minus minus plus, b y minus 3, c z minus 2 equal to 0. So this is the value of the equation of the plane. Now, second most important thing in this a, b, c is nothing but the direction ratio. This a, b and c, this is nothing but the direction ratio of the normal to the plane. Second important thing is, we know that when two planes are perpendicular to each other, then their direction cosine, a product of the direction cosine is equal to 0. So this is the very, very important condition. When the two planes are perpendicular, then their direction ratio product are equal to 0. Now, first plane is perpendicular to the plane. Now this plane, this is the first equation. This plane, this is the first plane. This is the first equation, and this is perpendicular to the two given plane. This is the given plane. So this is perpendicular to the given plane. So here also we can take x plus 2y plus 3z plus 5 equal to 5. So a into 1 here, 1, 2 and 3. So based on that, a plus 2b plus 3c equal to 0. Similarly, first is also the perpendicular to 3x plus 3y plus z equal to 0. So this also we can take as a into 3 plus b into 3 plus c into 1 equal to 0. So 3a plus 3b plus c equal to 0. Now, once we will solve the second and third equation, we will get the value of a, b and c. Now, a by, we know 2 into 1, this is the cross multiplication, and in this way we can find out this is the value. So a equal to this we took as a k. So a minus 7, b 8k and c equal to minus 3k. So this value we have to substitute in the place of a, b and c and get the value of k. So after substituting the value in the given first equation, we got this value, and after that this is the required equation of the plane. After substituting all the value, we are getting this is the required equation of the plane. Question number 14. If the point 1, 1p and minus 3, 0, 1 be equidistant from the plane, this is the plane, find the value of p. This is the unknown value that we have to find out. Now, the position, first of all, when the point is given, so first of all, we have to create the position vector of the both the point. So for the 1, 1p and minus 3, 0, 1, first 1, 1p, we can write the position vector, suppose a1, I plus j plus pk. Similarly, for the position vector of minus 3, 0, this is minus 3, not minus 4. This is minus 3. Minus 3i because minus 3 is here, plus k because this y value is 0, so plus k. This is a2. So according to the given point, we created the position vector of the both the point. Why it is required? Because later we will see the formula where position vector is required for both the point. Now, because it is given in the vector form, equation of the plane is given r dot 3i plus 4j minus 12k and plus d equal to 0. So this is the required equation of the plane. Now we know that perpendicular distance between a point whose position vector is a and the plane. So perpendicular distance, this is the position vector, suppose a, and this is the, suppose any plane whose perpendicular distance d. We know that the value is r dot n. This is the plane, this is the given plane, r dot n equal to d is given by, this is the perpendicular distance, that is a, position vector of the point normal to the plane minus distance from the origin divided by this value say. So whatever the value, just we have to take from the given plane and position vector. So from the given plane, n value is, this is the value, and d is minus 13, because when we are putting this equation r dot n equal to d, so this value will go right hand side, this value will go right hand side, so this becomes d equal to minus 13. So this is the two value we got here. So distance of the point, distance between the point 1, 1p and given by, so this is the position vector of this point, this is the position vector. After that, this is n plus d, because this is the plus d divided by, this is the value. So just we have to substitute the value, and from here we got the dot product, and this is the modulus value. This is d1 equal to 20 minus 12p by 30. This is the first for this point. Similarly, for the another point, we can find out minus 3, 0. This is also the same, minus 3i plus k, and this is the normal, plus 13 divided by, this is the value. So d2 value is minus 9, and just we have to find out the dot product. We got the dot dot product, and d2 equal to 8 by 30. So given that the distance between the required point is 1 p and minus 3 comma 0 comma 1, so d1 equal to d2, both the distance are same. So just we have to equate modulus value 8 by 13. So this modulus, if we will remove, then this is one time plus and another time minus. So this is plus and minus values. This is for the plus, this is for the minus, and p equal to 1 and p equal to 7 by 3. So in this way we can find out. So the most important thing is you have to know the formula and how to implement that formula. Question number 15. Find the equation of the plane passing through the line of intersection of the plane. This is the one plane, this is the another plane. So this type of question also called family of plane, where if we want to find out the equation of the another plane, p1 plus lambda p2 equal to 0. So this is the way, and to find out the value of lambda, some condition will give, like in this case parallel to x-axis it is given. So first of all, based on these two equation of the plane, we can create a equation of the plane which is passing through these two plane. So the given plane is this. So we first of all we have to write in this format, in the equation format, r I plus j plus k minus 1. This we have to take, and this also we can write here. Now equation of any plane passing through the line of intersection of the plane is, we can give here r dot I plus j plus k minus 1 plus lambda. That means this is the equation of one plane. Suppose this is p1 plus lambda, this is p2. So p1 plus lambda p2. Now after that r is common, so r we can take r here, r dot 2 lambda plus 1 I, 3 lambda plus 1 j, 1 minus lambda k. After that, this is the constant value 4 lambda plus 1. So we have to arrange this form. This is also the equation of the plane in the arranged format. So this is, if you will see here, r dot, this r dot n plus d equal to 0. This is the format. Now in this case, direction ratio of the given plane is 2 lambda plus 1, 3 lambda plus 1 and 1 minus lambda. This is the direction ratio. So required plane is parallel to x-axis. It is already given, required plane is parallel to x-axis. Now therefore it's normal to the perpendicular to, it is normal is perpendicular to x-axis. So the most important thing is here. So whenever the condition is given, required plane is parallel to x-axis, that means its normal is perpendicular to x-axis. Now, after that x-axis value is direction ratio of x-axis, we can tell 1, 0, 0. So this is also the direction ratio for this condition, and this we got direction ratio for now. After that, just we have to multiply these two. 1, 2 lambda plus 1, 0, because the condition for the perpendicular, 3 lambda plus 1, and this is 0. Lambda value is minus 1 by 2, and at the end we have to substitute in the equation first. So whatever the equation we got in the first, this is the equation first we got. Just we have to substitute the value in this lambda value. If we will substitute here, then this is the required equation of the plane. So first equation become r minus r bracket minus j plus 3k plus 6 equal to 0. Now its Cartesian form easily we can write here. X value is 0. So y, this is y minus 3z plus 6 equal to 0. So this is the required equation of the plane. So this is very, very important questions. Question number 16. Let O be the origin and coordinate of P be 1, minus 1, 2 and minus 3. So one point is given origin, that is 0, 0, 0, and another point is given 1, 2 and minus 3. Find the equation of plane passing through the point P Suppose the plane is passing through the point P and plane is perpendicular to OP. Now, suppose the plane is perpendicular to OP. Now, try to understand the most important, very, very important thing is here. First of all, when the 2 point is given, the first our task is to find out the direction ratio. Second, our task is here to find out the equation of the plane when it is passing through one point. So A, x minus x1 plus B, y minus y1 plus C, z minus z1 equal to 0. Now, when we are finding out this, after that, the most important thing is how to find out the ABC value. So very, very important thing, just remember, when any plane which is perpendicular to the line joining the 2 points, so whatever the direction ratio we are finding out for this, so direction ratio for this also same. Always remember this, this is very, very important. So based on that, whatever the things we discussed, so coordinate of O and P are 0, 0, 0 and 1, 2 and minus 3. So first of all, we have to find out the direction ratio of OP, which is 1 minus 0, 2 minus 0 and minus 3 minus 0. So we can write 2 minus 0 and this is 1, 2 and minus 3. This is the direction ratio of the 2 points. Now, equation of the plane passing through any point x1, y1, z1 is ax minus x1, by minus y1, cz minus z1 equal to 0. Where ABC is the direction ratio of normal. This is very, very important. Direction ratio of the normal. Hence, if we will see here, so point is given 1, 2 and minus 3, it is passing through. But the direction ratio of the given plane is nothing but the 1, 2 and minus 3. This is only the direction ratio of the normal to the plane. So direction ratio of normals are 1, 2 and minus 3 and the point from which it is passing, that is 1, 2 and 3. Just we have to substitute both the value in the given equation and we get here x minus 1, direction ratio 1, 2, 3, 1, 2 and minus 3 here, and point is 1, 2 and minus 3. So just we have to substitute and we got the required equation of the plane. So this is very, very important question. Question number 17. Find the equation of the plane which contains the line of intersection of the plane. This is one plane, this is another plane. Here also the same concept. First is family of line. So family of line, whenever the two plane is there, P1 plus lambda P2 equal to 0. This we have to write. So based on that, we create the two equation of the plane, family of plane here. Now, once we will find out this P1 plus lambda P2 and after that rearrange the term which is perpendicular to the plane. So one plane, so whatever the direction ratio we will get from here and direction ratio of this. So A1, A2, B1, B2 plus C1, C2 equal to 0. So whatever the value of lambda we got, just we substitute, we will get the equation of the plane. So in this way only we can find out. So this is the two-step process. Now, just we can see, so this is the line of intersection of the plane. First, we have to find out the equation of the plane, which is passing through the two plane. So this is the first equation and this is the second equation. So required equation of the plane we can write here. Equation of the plane passing through the intersection of the plane first and second we can write here. This R and this is lambda. This is the another. Now, after that same process, we have to arrange R dot. After that, this is the like I value. We can write here 2 lambda and here 1. So 1 plus 2 lambda plus 1. Similarly, here lambda into 1. So lambda plus 2. Similarly, 3 minus lambda. And after that, this is the constant value and this is the 5 lambda. So 5 lambda minus 4 equal to 0. So this equation of the plane is perpendicular to the plane. And this is the another plane which is perpendicular to this plane. So whatever the direction ratio 2 lambda, lambda plus 2 and 3 minus lambda, and here direction ratio 5, 3 and minus 6. Just we have to multiply A1, A2, B1, B2, C1, C2 and get the value of lambda. After getting the lambda, we have to substitute the value of lambda in the equation third. In this equation, we have to substitute. So after substituting the value, we are getting here. This is the just after substituting the value, we are getting r dot, just solving this, and we are getting this is the equation of the plane. Now this is the vector equation. To convert this it into the Cartesian equation, so only we have to check the r value, that is r is position vector. So the Cartesian plane can be written by r equal to xi plus yj plus zk. We have to substitute and we will get there just by the dot product of this is nothing but 33x 45y plus 50z minus 41 equal to 0. This is the same equation in the Cartesian plane. So this is the way we can find out this. Question number 18. Find the distance of the point -1, -5, -10 from the point of intersection of the line. This is the line and this is the plane. So first of all, in this type of question, what is the step? First, we have to solve the equation of the plane and the line. So how we are solving? Just we have to substitute the value of r here and arrange the term and find out the dot product. So this is the point of intersection. Point of intersection we got for the line and plane. Now this is the first. After that, we have to substitute the value of this, whatever the point is there. This is the first thing. We have to find out the point of intersection. This is the first thing. Now we will get the, just you can see here, r equal to this second equation. Equation of the given plane is r I minus j plus k equal to 5. So we have to write the value of r, we have to substitute here and just we get the dot product of this line and the plane. So 2i, just we have to substitute lambda. Now arrange this line, this we have to arrange, and after that we have to take the dot product. So this is nothing but a 3 and here 2, 3 lambda plus 2i, 4 lambda minus 1j, 2 lambda plus 2k, and this is I minus j plus k. So this value of I, this value of I, this is 1 and this is 3 lambda plus 2, this is 3 lambda plus 2, 4 lambda minus 1 and 2 lambda plus 2 equal to 0. So lambda equal to 0. After getting the value of lambda, we have to substitute in the equation of the line. Substitute the value in the first, that is equation of the line, and we get r equal to 2y minus j plus 2k. That means position vector of the point, like this is the plane and this is the line. So the position vector of the line and the plane we got. So position vector of the point of intersection of the line and plane is this 2i minus j plus 2k. So it indicates here point of intersection of the given plane is given by the, and the point plane and the line point of intersection is 2, -1 and 2. And another point is given -1, -5 and 10. So for the distance formula, we will apply the formula x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. So this is the most important thing to find out the point of intersection. So after that, we have to apply the distance formula. 2 -1 -2 whole square. This one, after that -1 plus 1 whole square minus 10 -2 whole square, and the value is 13. So in this way, we can find out the distance between 2 points. Question number 19. Find the vector equation of the line passing through 1, 2, 3. This is the point 1, 2, 3 and parallel to the plane. This is the one plane r dot. This is the r dot not equal r dot I minus j plus 2k equal to 5 and r dot this value. Now in this case, let required line be parallel to vector b. So it is given by, suppose the vector we are taking here B. So Bi plus B2j, B1I, B2j, B plus B3k. So position vector of the point 1 to 3 in terms of ijk, first of all we have to create the position vector of 1 to 3. So A equal to I plus 2j plus 3k we can take. Now equation of the line passing through 1, 2, 3 and parallel to given vector is given by. So this is the very important equation. So any equation of the line we can write if the point is given and parallel to a given vector, so r equal to a plus lambda b. So this is the position vector, this is the position it is representing through which it is part, this is nothing but the point, and the vector which is parallel to this vector b. So this is the vector b, b1 I plus b2j plus b3k, and this is the r equal to, this is r equal to, this is r equal to. Now after that, equation of the given plane, the two planes are given. So that is r dot I minus j plus 2k equal to 5 and r dot 3i plus j plus k equal to 6. This is the two plane. So the line in equation 1 and the plane in equation 2 are parallel. It is already given. So line and plane are parallel. So if the line and plane are parallel, so normal to the plane of equation 2, in this normal to the plane to the equation 2 and the given line are perpendicular. So this is the important concept here. So whenever the line and plane are parallel, that means what is the meaning of that? We can take normal to the plane of the equation. This equation normal to the plane, that is normal r dot n, this is value normal to the plane of equation and the given line are perpendicular to each other. Now based on that we can take here I minus j plus 2k, this is the value I minus j plus 2k dot lambda b1 I plus b2j plus b3k. So after that we have to find out the dot product, and this is lambda value is there, and this is b1 minus b2 and 2b3, and lambda is constant. So b1 minus b2 plus 2b3 equal to 0. Similarly for the line and another plane, that is nothing but 3i plus j plus k and lambda b1 b2 b3. So here also 3 b1 b2 and b3. So this is 3 b1 b2 b3, this is the equation 5. So from the equation 4 and 5, once we will solve this equation 4 and 5, we can write here b1 by minus 3 b2 by, this is the cross multiplication, just you can solve easily, b1 by minus 3 b2 by 5 and b3 by 4. So the direction ratio of b are nothing but the minus 3, this is minus 3, 5 and 4, this is the direction ratio. So b equal to b1 I, b2j, b3k, and this is the value of b. So minus 3i plus 5j plus 4k. So just we have to substitute the value of b in equation first. So r equal to, this is the position vector 1i plus 2j plus 3k and lambda, this is the required equation of the line. So this is very important question. Question number 20. Find the vector equation of the line passing through 1, 2, minus 4, and this is perpendicular to the two line. This is the two line is given. So in this case, first of all, let the required line be parallel to the vector b, and that vector b we can write here b equal to b1i, b2j and b3k. So position vector of the given point we can write 1, 2, minus 4, that is a I plus 2j minus 4k. So equation of the line passing through the 1, 2 and minus 4 and parallel to the given vector. So first of all we have to create a equation of the line when it is passing through 1, 2 and minus 4 and the which is parallel to the given vector. That we can write here r equal to a plus lambda b. So a is nothing but the position vector and this is the which is parallel to the vector b. So equation of the line, when it we will arrange this. Now this is the first equation, and equation of the line, it is given here x minus 8. This is the two equation, this is second and third. Now line 1 and line 2 are perpendicular to each other. So if they are perpendicular to each other, then their direction ratio or product of direction ratio is equal to 0. So in this case, now 3 into B1 minus 16 into B2 plus 7 into B3. Just we can B1, B2, B3, and this value, whatever that in the denominator, this is equal to 0. Now, similarly, first and third line are perpendicular. This also we can create 3b1, 8b2 minus 5b3 equal to 0. So we have to find out the b1, b2, b3. Just we have to solve equation 4 and 5. So just by solving b1, we can write here, already we know the cross multiplication. So b1, we can write here minus 16 minus 5. After that, minus 8 into 7. So this will give the b1. Similarly, b2 we have to write. Now we have to write the b2 value. So just I am explaining how to do the cross multiplication of this. So b1 we can take here. After that, just we have to multiply this value and this value. So we will get this. After that, b2 we can multiply. When we will multiply b2, after that, first we have to take this side, and after that this side. And third, b3 we have to find out. So first 3 into 8 minus 16 into 3 minus 16 into 3. So b1, b2, b3, when we will take, this is the value, and this is nothing but the direction ratio of b is nothing but 2, 3 and 6, and b we can write here 2, 3 and 6, b1 plus b2 plus b3, and this is the direction ratio, and we will get the value of b. Now this we have to substitute in the equation first. R equal to I plus 2j minus 4k, this is the position vector, and b we got just by solving 2i plus 3j plus k. So this is the required equation of the given line. Question number 21. Prove that if a plane has the intersect A, B and C and is distance of P unit from the origin, then this is the value, this we have to prove. Now the equation of the plane having intersect ABC with x, y, z axis respectively is given by, already we know this result, x by A plus y by B plus z by C equal to 1. Now distance P of the plane from the origin is given by, suppose that this is the, so 0, just we have to, and we know this the point 0 comma 0 comma 0, and this is the line x by A plus y by B plus z by C. So in this, what we have to do, just we have to substitute the value of x, y, z value, and this is minus 1. This we have to take mod divided by 1 by A square plus 1 by B square plus 1 by C square. In this way, we can find out the perpendicular distance. So distance of P of the plane, it is same like a straight line. So distance of P of the plane from the origin, we can find out this, and this is the P value 1 by A square plus B square C square, and just squaring this, and this we got the result. Now distance between two planes, 2x plus 3y plus 4z, and if we will see this, both the planes are parallel because we are getting this two. Just we can see here, both are nothing but the ratio 2 by 4, 1 by 2, 3 by 6, 1 by 2, 4 by 8, 1 by 2. So in this case, how we are finding out the distance between two lines? Similarly, we can find out the distance between two parallel lines. So first of all, we have to make the coefficient equal. So this value is first plane. Now, once we divide by 2, we are getting this. So after that, d1 minus d2 divided by A square plus B square plus C square. So this is the required value of D. The plane 2x minus y plus 4z equal to 5 and 5x minus 2.5y plus r. What are the conditions that we have to find out? So when we will see here ratio and product of the direction ratio that we can see. So A1 by A2 is 2 by 5, B1 by B2 is also 2 by 5, and C1 by C2. So definitely they are parallel to each other. So this way we can find out. So I hope this is crystal clear for all of you. All are very, very important questions for the point of examination. So you have to do the practice and command on this exercise. Thank you.